Last week in AI, here we go. Talking about Gemini, don't you know? Gen-3 Alpha 2, so fun. Get ready for a wild ride. Tune in and we'll make it fun, you see. From AI agents to Chevron, deference with glee.
Hello and welcome to the latest episode of Last Week in AI, our podcast where you can hear us chat about what's going on with AI. And as usual, in this episode, we will summarize and discuss some of last week's most interesting AI news. And as always, you can also check out our Last Week in AI newsletter at lastweekin.ai for articles we did not cover in this episode. I am one of your hosts, Andrey Kurenkov. For some context, I did a PhD in AI at Stanford that I finished last year, and I now work at a generative AI startup.
And I'm your other host, Jeremie Harris. I'm the co-founder and CEO of a company called Gladstone AI. We do AI and national security stuff. And, we've had a bunch of really useful feedback lately on the podcast on a number of different things. One of them was that apparently the sound coming from my end was shit. And so we're going to try to fix that today in a couple of different ways. I'm recording locally, but I also moved my microphone closer to my face. And so for those of you who are watching on YouTube, you probably like that because it takes up a lot of the space that otherwise my face would in the shot, which is probably a good thing. Anyway, so going to try to get you guys some better sound quality this time around and hopefully a bit of a smoother ride. So anyway.
Yeah, let's hope so. I actually like it in frame because it makes it feel more like a professional podcast as opposed to what it is, which is like two guys who have full-time jobs just doing this on the side, with one of them like fully a non-audio engineer taking care of editing. But we try our best. Shout out to the person who pointed us out. Yeah. Jinga Rocks on Apple Podcasts got us a 3-star review, which is not great, but
how dare you?
Useful feedback, and we will try our best to take it into account and do better. We'll see if that actually works.
Plus, we look more like Larry King this way. Which, plays into our ongoing strategy to gradually turn into Larry King, because that is the thing that people would want to do for some reason.
Okay, news to me that that's the goal, but I guess we'll see if that works out.
I thought we were completely aligned on that, but okay.
And real quick, just another shout out to another review. Green Pooh via Apple Podcasts has a review titled "Keep the Doom."
Keep the Doom. Okay.
Yes. It says keep the doomsday stuff, please. I'm not sure how this became a whole saga.
I think there's a war playing out right now in our comment section. And
Yeah, so we'll try to appease everyone, maybe a little bit of doom every now and then.
Just a little bit of doom.
Yeah. And that's the news, starting with tools and apps. The first story is Google opens up Gemini 1.5 Flash and Pro, with Pro having 2 million tokens to the public. So this is in Google Cloud, and these two models are now publicly accessible, with Gemini 1.5 Flash being a small multimodal model that is more for high-frequency tasks, and Gemini Pro is the most powerful version of their Gemini LLM, and notably has a 2 million context window, 2 million token context window. That's the amount you can have in the input. And for some context, that is a lot. That's like 60,000 lines of code, over 1.5 million words. So this is one of the big surprises to me over the past year. If you remember in the early days of GPU-3, the inputs we could get are like 2,000, 4,000, relatively small. And I felt that this would be one of the fundamental limitations of a transformer model, and it turned out to be not the case at all. So there you go. It's certainly an exciting day for developers, and these are some pretty capable models. So pretty nice to have.
And they're really starting to compete on those sort of secondary metrics, right? We all often talk about, like you said, context window length. You talk about, sometimes perplexity or whatever, but we're starting to see stuff at the engineering level really become the main sort of point of comparison as inference gets more and more important. So here in particular, they'll tell you Gemini 1.5 Flash is, they say, 40% faster than GPT 3.5 Turbo. That's at an input of about 10,000 characters, which seems pretty fair. So that's basically saying, hey, we have 40% lower latency. They also apparently have an input price per token price that's 4 times lower than GPT 3.5 with this thing called context caching enabled for these larger inputs, which is its own kind of interesting sub-announcement in this whole thing. They're launching this, what they're called this context caching feature as a public preview right now. This is both for Flash and Pro at Gemini 1.5. This is basically a thing that allows models to store and reuse information they've already kind of processed without having to recompute everything from scratch every single time they get a request, right? So think about like your sort of short-term memory. I assume that they're using just kind of embeddings to achieve this. So it's like kind of a middle ground with RAG. Anyway, so really interesting. Another cost-saving strategy, keep the things in context to not have to reprocess them. That all seems to be part of the sort of the turning this into more of an engineering, not more of an engineering discipline, I guess, but more of a user-facing productized thing rather than a research artifact that we're seeing across the industry right now.
Yeah, that's a very good call out. I think this caching feature is more of a big deal than it might seem. To me, it's been a bit surprising that it hasn't already been the case. The idea here is if you're using kind of fine-tuning these LLMs via just a system prompt, you condition them to say, this is your task, blah, 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 blah. If you just reuse that without any modification, it makes a lot of sense that you're able to cache this. And I actually looked around, there aren't, except for this, existing cloud models that allow you to do this. So probably pretty useful. One other note that also is in the story, apparently there was a press briefing in which the Google Cloud chief executive said that a lot of organizations, big ones like Accenture, Airbus, Box, Broadcom, etc., are building on the platform. And this is one thing also not to discount, that, Google may have seemed to be behind OpenAI in developing Gemini, but they are a big company that is certainly ahead in terms of being able to provide enterprise offerings on its cloud platform. So it makes a lot of sense that these kind of big companies would work with Google, potentially Microsoft and Azure as well, but certainly Google does have an edge here that may be not apparent.
Yeah, they often talk about the importance of distribution, right, as the central thing. The example I always remember from back when we're doing the YC stuff, I think Microsoft Teams versus Slack is just such a great example, right? Slack launches, they get this like slow, steady increase in user traffic. I mean, it's very fast, right? This is a successful Silicon Valley company. But Microsoft Teams launches and their stick looks like a hockey. Their graph looks like a hockey stick in comparison because they start with all this insane distribution. And you see OpenAI trying to kind of make up for that deficit by partnering with Apple, by partnering with Microsoft. But ultimately, Google has that baked in, right? So this is a structural advantage that they enjoy over OpenAI. Much more so. So kind of interesting, yeah, that this is something they don't have to worry quite so much about. It is an axis they can use to differentiate on and just kind of like force users to start using their products, essentially.
And next, another big company, Meta is about to launch its biggest Llama model yet, which is a Llama 3 400 billion. So when Llama 3 came out with the 8 billion and 70 billion parameter sizes, we also got a bit of a preview with the awareness that this 400 billion parameter exists, that it is GPT-4 kind of level model that they were still training, which was kind of a funny note that they had. And they showed that on the major benchmarks, it was matching GPT-4. So apparently it's nearing release now, a couple months later. We don't know if it will actually be released and open sourced the same way as the smaller sizes have been, but it does seem like now it's being rolled out in some of the Meta products, such as on WhatsApp for beta users. There's an option to use the Llama 3 405 billion model.
Yeah, and these use cases, even these really beta ones, do seem to have significant limits on usage volume. So, just to kind of get people stoked about the upcoming release, this article is, speculating July or August of this year. We'll have to wait and see. One of the things I suspect that they're going to be struggling with here is making sure that the model can't be jailbroken as trivially as the other Llama 3 models can be. This has been a persistent issue for Meta, as they've, in some cases, been embarrassed by congressional testimony. Zuck got dragged in front of some committee or other, and I think I'm trying to remember if Tristan Harris or who it was exactly who sort of held up this jailbroken version of Llama 2 at the time. And Zuck was saying, you can't do these bad things. And he said, well, look, we took your model and basically trained it just a little bit, and it forgot all of its safeguards, and now we can get it to try at least to do some bad things, even if it couldn't successfully execute them due to a lack of capabilities. So I think this is going to be a big issue, because when you start to think about models that are like Llama 3, 400 billion, right? This is a model, as you rightly said, that's been compared internally by Meta to GPT-4 level performance. Well, what are the things that we know GPT-4 can do? There's things like autonomously discovering and exploiting, 1-day vulnerabilities, 0-day vulnerabilities, leading to significant measurable lifts in cyber offense capabilities, even to some degree on bioweapon design capabilities. And so, we're already there. You start to open source those systems, that can create some problems. So internally, I do wonder what that discussion sounds like. I wonder what kinds of safeguards they're planning to implement. Because it's not even just like, hey, let's implement safeguards that are robust to the jailbreaking techniques that we know of today. They have to be robust to jailbreaking techniques that have not yet been invented. And it's really not clear, how you square that circle. So I'd love to be a fly on the wall right now in the red teaming rooms at Meta and the kind of decision rooms where they're thinking about, the pros and cons of releasing that 400 billion parameter model. But if it comes out, it'll be a very, very big deal.
Yeah, for sure. And I think there's really no way, given what we know about jailbreaks, if you're able to train the model, you can't safeguard against it. It's just impossible. So this is one of those questions that has been discussed a lot in open source, is what's the benefit versus the risk of releasing models and enabling actors to misuse them to nefarious ends. And so we'll have to see what consideration Meta makes on this one. And if it's released, maybe that's a doomsday scenario kind of conversation.
I think we're a little far from there, but you know what? Maybe the 4 trillion parameter version.
Yes, the next one, Llama 4.
It's always a 10x away from here, right? That's what they always say.
On to lightning round. First story is Runway's Gen-3 Alpha AI video model is now available. So this was announced and previewed very recently. I think we covered the kind of announcement and some of the preview videos last week. They said that it would be available to users of their products very soon, and that has turned out to be the case. It is now available to paying users. So you have to pay $12 a month to be able to access a model. You will now be able to generate videos up to 10 seconds, and the generation speed will vary. And it's not quite Sora level yet, but it is a big upgrade over Gen 2. And there aren't many players that have launched these sort of tools. We've seen Llama do that, but that was sort of a public preview. We don't have many customers yet, to my awareness. So Runway has been in the game for a long time. This is a pretty impressive model. They've caught up in some sense. So I wouldn't discount them even as Sora and things like that are coming out.
And like you said, there are other competitors entering the space. You mentioned Llama, Stability, obviously Pika, OpenAI itself with Sora, though that hasn't been released. So the space is heating up a little bit. They had been working pretty quickly back in the Gen 1, Gen 2 days. Runway had, that is, pumping out those models pretty quickly with a few months between them. The big kind of gap that we've seen is really when all these extra players have come in. So I think that's, now people are starting to ask those fundamental business questions, especially looking at the situation with Stability, where this, open source everything story just did not seem to pan out. Andrey, I remember we were talking about that back in the day, being like, what is the business model here? Like, at some point, you got to make some dollars. And I get that you can do it in various interesting ways by hosting and all that stuff. But at a certain point, you need a competitive moat. And it looks like, again, offering some users access to paid versions of these products does seem like it's an obvious default. So we'll see if that becomes the norm more so on the kind of generative video and image stuff. But one thing that they do say is that the model is currently runs with text to video, obviously, but in the coming days, they'll be releasing other modes. So that'll include apparently image to video and video to video. that's going to be really interesting. Like what new editing possibilities are accessible as well. Right now, they are capped at 10 seconds of video generation, right? So, Sora famously is a minute long. So this is 10 seconds. But then again, so hard to compare it to Sora because like we don't have access to it. It hasn't been released for general use. So we'll just have to see. But definitely, big step on the path to productization of text to video. This is a big day.
One thing to note about Runway, as someone who has played around with it and has kept track of a company, it's worth knowing that they offer a lot of stuff aside from the video generation. They offer background removal, kind of optimization of video, outpresing, all these things that as a professional in the industry, most likely you would get a lot of benefit from beyond video generation, which is pretty unproven and is like a cool thing to fundraise and get money from investors for, but not necessarily something that people need at the moment. So I don't know. I don't know why I want to say this, but I'm kind of a fan of Runway, and I like to see them having these tools that seem like they would have a pretty significant impact. And then, as you'll cover, they are hoping to fundraise quite a bit soon.
And you use it at your current job, like the video game?
I don't use it. I've played around with it.
Oh, you have? Okay.
Just for fun.
I'm always curious with the work that you're doing there, to know, well, like what tools are actually useful when you're doing generative AI for video games. So anyway, that's cool.
And next, we are getting to Google as yet another big company. And the news there is that there is some AI that's coming to their Pixel 9 smartphone. So this is basically a set of various features under a branding of Google AI. Things like Add Me, that ensures everyone is in a group photo, Studio, which is AI image generation, Pixel screenshot that evidently will be similar to Recall, where you can take a screenshot of a phone and talk to the AI about that. So these various built-in things coming to Google phones in a way, I think, reminiscent of some of the announcements of Apple building stuff into iOS. And we'll see how much people like it or if they just ignore it.
Yeah, and this is Google continuing to try to figure out how do we integrate everything under one hood here, right? So we'll see if it sticks.
Next, AI firm ElevenLabs sets audio reader Pact with Judy Garland, James Dean, Burt Reynolds, and Laurence Olivier. ElevenLabs is the audio generation firm that has allowed people to turn text to voice. And recently they announced this reader app, which essentially provides narration for any text. Now it seems that they have had these agreements to have the voices of these famous actresses and actors to do that reading for you. They say this would be part of the iconic voices feature of the app. So I don't know, interesting. Apparently this hasn't been met with quite as much controversy. It was a pretty legit deal, a licensing deal. The daughter of Judy Garland has endorsed the deal. So I think you, as a user, right, you want sort of a professional narrator rather than a robot voice. So certainly I could see why people might want to use this.
Yeah, no, for sure. It's interesting. This is almost like the soft underbelly of how to get, automated text to audio done without pissing people off, while still really having the same effect that a lot of people are complaining about. I think we talked about this in the context of a couple, I guess, like almost 2 years ago now. So I wrote this book and I did the audio book for it. And it was time consuming. You're sitting in the studio. It's like 16 hours of painful recording. And if you don't do it as the author, someone else does. There's a whole industry of people who will read the kind of text of a book and do the audio. And people were saying, well, there was a scandal. I think at the time we were talking about a scandal where companies were selling access to those audiobooks, the sound that was being read by those on contract readers, and saying, hey, you can't use their own work to automate away their whole jobs. Well, this is a way around that, right? You go to people who aren't going to be producing any more work like that because they're already dead. You go to their estates. That's one good way to do it. But it achieves roughly the same end. So, maybe not as controversial, but again, achieving the same ends. And we'll see if this becomes a a norm. I think just given the cost of doing a lot of these recordings, the whole studio time, multiple employees, sound engineers, like this could really be a thing.
Next, Perplexity's Pro Search AI upgrade makes it better at math and research. Perplexity is, of course, the AI-powered search engine that basically you can use, input a query, it does search online and looks up various websites and then provides an answer informed by that. So they have now upgraded the Pro Search feature, which would be the thing that you have to pay for. And there's a couple things in there. They now have an updated Pages feature, which we covered a little while ago. And here they say that it's going to be better able to understand complex queries, plan responses, and synthesize in-depth answers outside of that Pages feature. Interesting. Yeah, Perplexity is one of the, pretty buzzed about companies. I think Jensen Huang said that he uses it daily. I've played around with it, and I would say it seems quite useful. So makes sense for them to keep kind of pressing the advantage they have in this space.
It's also the kind of thing that is so much easier for Perplexity to pull off because they don't have all the baggage of the sort of legacy use cases that a company like Google, which nominally they frame themselves up as competing directly with, has. And so they're able to just sort of be more sort of open horizon about what their product possibilities are. Just looking at the demo that they've got, it looks pretty compelling. You type in a search query like, I want to see the Northern Lights. When is the best time to go? And what are the top viewing locations in Iceland or Finland? And you click on the Pro Search thing, and it sort of automatically goes through like any good web agent would to dig up the answer to your question in a way that's a little bit richer and more detailed than necessarily you would get through a standard search process. So yeah, we'll see if this is actually the use case people want. One of the things that does jump to mind when you start to introduce this kind of use case is, again, inference latency becomes so much more important, right? You're just watching as this thing kind of thinks about your question. And as I imagine myself as a user, right, my UI, like my user experience is that of like just hanging on while this thing chugs away. That may or may not be what I want, but as you start to see the efficiency of inference, the cost of inference, and the time of it go down, these things might become more and more attractive. So Perplexity is definitely positioning itself through this to do some really interesting things.
And just FYI, we call it just now, if you remember the silly things that Google's AI responses did of recommending people eat rocks. Well, people did also check out what Perplexity does there. And surprise, Perplexity did not recommend that you eat rocks. It actually recognized that it was silly and pointed out that there were some sarcastic responses. So it is a pretty polished product in this category. And last story for the section, Gemini's data analyzing abilities aren't as good as Google claims. These are some studies that showed that for large data sets, the correctness rate is fairly low. Apparently, they give the right answer only 40 to 50% of the time. The tests here are basically evaluating true-false statements about fiction books. And for these large portions of a book, which has implicit information that is not stated in the text, apparently these models aren't that great. And this is one of the kind of questions that is still out there for these huge context windows. How good are they in practice with giant inputs? I don't think we know the answer yet, really. And these studies do shed some light on that.
Yeah, there's some important framing here too, which is that it's not here that Google is behind the curve or they're doing things badly on a technical level. The complaint here really is about what Google's marketing department has been doing, basically overpromising, under-delivering. Google's obviously delivering excellent products. Gemini 1.5 Pro, 1.5 Flash, these are really impressive models. The challenge is that when you go out there and say, hey, we can actually solve these very complex data analytics problems, maybe not quite the case, or cherry pick things. It's something we've seen with Google before, right? We've covered stories where Google's come out with an impressive demo that doesn't quite seem to be kind of live up to the hype. And that's maybe a bit of an internal issue for them. The right hand not knowing what the left hand is doing, perhaps, or the marketing department just kind of getting ahead of itself. One of the things that does come across in these studies is kind of interesting. The old needle in a haystack eval, which is the way very often these models' ability to recall information out of a really, really large body of text is tested, is to insert a very specific piece of information, like one sentence that is like out of place somewhere in a really long piece of text, and testing to see if the model can actually recover that sentence correctly. And what they're pointing out here is that they noticed, and this is a quote from the article, we've noticed that the models have more difficulty verifying claims that require considering larger portions of the book or even the entire book compared to claims that can be solved by retrieving sentence-level evidence. So when the information you're trying to recover is more diffuse, when you have to put a lot of things together, all of a sudden your accuracy goes down a lot. It's not a pure recall test, it's a recall plus synthesis test. And I think that's a really interesting thing that highlights, a kind of eval that we haven't seen done, certainly not nearly enough of when we look at these big models in long contexts.
Yeah, and I think it makes sense. We've seen kind of in the earlier days of large context windows, Anthropic showed that you could do really well on these sorts of tests by just appending, present the most relevant sentence in the prompt for these needle in the haystack benchmarks. And it has been sort of criticized that, yes, it's a needle in a haystack, but it's a very obvious needle that really stands out. So these benchmarks, I think, haven't really shown how useful these context windows will be in practice. And this sort of research is very informative. On to applications and business. The first story is that Quora's chatbot platform, Poe, allows users to download paywalled articles on demand. So you can download HTML files for articles published by paywalled journalistic outlets that includes things like the New York Times, Bloomberg, Businessweek, The Atlantic, and all of these other big services. We saw also the claim being made that Perplexity does this for Forbes, where they look at the article and can produce kind of verbatim responses without really citing the source, but not that much. And in this case, it also appears to be a case that the bot does not appear to adhere to the robots exclusion protocol, which is a web standard that prevents bots from accessing parts of websites. So really interesting developments in this front, where the internet and any publisher of information, such as journalists and things like Reddit, Twitter, are now really having to consider blocking downloads of data, which we've had paywalling for users, but it has been fairly easy to get around those paywalls if you tried at all. And I think that's going to change very much.
Yeah, absolutely. And it's really interesting to see the legal arguments that are being made to say like, hey, this isn't really plagiarism. There's this one quote that they pull out from the article, and they say like, because they made a copy on their own server, that's prima facie copyright infringement. That is going to be the claim that the newspaper organizations put out. They flag that Quora disputes this, comparing Poe to a cloud storage service. So which one is it, right? In practice, it seems like you really can just use these systems to get a downloadable PDF. To me, naively, from a user experience standpoint, feels an awful lot like plagiarism. But they say also, to your point, right, that according to the web server's logs, that for the websites that essentially are hosting these news stories, immediately after the assistant bots were prompted to summarize text on the site, they found a bot identifying itself as QuoraBot that visited the site. Apparently, as you say, it did not attempt to visit the site's robots.txt page. So that robot standard, Andrey, that you just mentioned, it's kind of worth flagging. I think we might have talked about it before, but on a lot of websites, if you go to whatever.com/robots.txt, you'll see there like a list of bots that are actually excluded by name. So you'll see QuoraBot explicitly listed or whatever. And that tells you, okay, this page cannot be scraped by the Quora bot or by whatever the bots are that are there. The suggestion here is that essentially that protocol is being completely ignored. And, especially at a time when we're starting to figure out like, hey, do people by default have a right to not have their website scraped? Or do they have to put it on the robots.txt? Or will companies ignore that? And does the law have to intercede? Do we need new laws? That's a kind of interesting exacerbating point. If you notice in practice, people are ignoring these sort of like goodwill requests implicitly through the robots.txt file. So yeah, really interesting. The core argument here is the file attachments on Poe are created at the direction of users and operate similarly to cloud storage services, read it later services, and web clipper products, which we believe are all consistent with copyright law. So that's, anyway, a whole bunch of interesting stuff there just to say, if you're the one who is on a one-off basis, clicking something and that's what generates the summary, they're claiming, oh, well, that's, then that's not a sort of a copyright infringement. So anyway, kind of interesting. I don't know that I buy it personally, but hey, again, we got lawyers who listen to the podcast. So let us know if you think this is a good argument.
Yeah, all these things are so much up in the air, but it does make me think with these stories about Quora, with Perplexity, it really starts to make sense that OpenAI has been doing all these media partnerships over the last couple of years, really been aggressively pursuing, paying different outlets millions of dollars to train on their data, but also to include their data in their outputs, to refer to them, cite them, right? And if it does come out that for paywalled websites, you cannot read the website to generate a response, then this could be one of the big competitive advantages of OpenAI.
Yeah.
Right. As of now, it's a little bit interchangeable using GPT-4 versus Gemini versus Anthropic. They're a little bit different, but not that much. But once these tools can be differentiated by partnerships, they do become quite a bit different. And depending on your needs, it may make a lot more sense to use OpenAI rather than anything else. So yeah, developing a sort of paradigm that I don't think we really expected or thought about last year.
Yep. And now OpenAI signing with Time Magazine. So there you go.
Yeah. And on to the lightning round, where we'll try to be a bit quicker. First, hardware story: Huawei and Wuhan Xinxin to develop high bandwidth memory chips amid US restrictions. This is a report reportedly planning to develop these high bandwidth memory chips. And as we cover all the time, China does need some means of producing different types of chips to actually compete in the AI front. GPUs, but also these high bandwidth memory chips. And so it makes a lot of sense. Huawei has been one of the leaders in providing AI hardware that NVIDIA is still the leader in. Now, these companies have denied this report. They said it's a rumor, but who knows?
Well, yeah, I suspect the rumor is true on this one, but yeah, they've got a really clear reason to deny that. They're basically fearing more U.S. Sanctions, right? So Huawei had the hammer come down on them when they announced to the world that, hey, we partnered basically with SMIC to create a sanctions busting 7-nanometer technology a couple months ago. And then, the US came down hard. They're expecting that to happen again if they're not careful about this sort of thing. One thing just worth flagging, the one thing I'll say about this is, from a technical standpoint, this is about high bandwidth memory, right? HBM, really critical technology, distinct from what you might think of as logic, sort of like logic chips, the logic on the chip that TSMC, for example, really specializes in. So the logic piece is the piece that runs the calculations. It's usually really, really close to, this thing called SRAM on the chip, a really, really small amount of memory that's just for like working memory. The high bandwidth memory is what you need in order to move the massive amounts of data and all the model weights and the gradients and the activations that you need to run through your system while you're training or doing inference at scale. So it's more of a kind of pipes thing than a number crunching thing. But both are really crucial. And we talk a lot about TSMC on the podcast. They certainly are the leader on the logic side. When you look at high bandwidth memory, the kind of big players there are more like SK Hynix and Samsung. So each of those, they control about 50% of the market share in this space. So this is really China saying, look, we have Huawei SMIC working together to figure out the logic piece. And now essentially we've got other players as well on the high bandwidth memory piece. And that's really what Wuhan Xinxin is up to here. And that's gonna that's going to piss off the U.S. government if they make any big breakthroughs here. But it's early days for this category of tech. They very much are behind here.
And next story also on a Chinese company, this time Alibaba. And the story is that its large language model has topped global ranking of AI developer platform or on developer platform Hugging Face. So on Hugging Face, that's one of the sources for ranking AI models. And now 3 of the top 10 ranked Chinese LLMs of Hugging Face have these Qwen series models, Qwen 72B, Qwen 1.5, 110B in 3rd and 10th places, respectively. The other one on there is Yi 1.5 34B chat from the startup O1.ai, founded by the notable figure Li Kai-fu. That was ranked 7th. So we see now competition coming around in the space of models in China, similar to Anthropic and OpenAI and Google out in the US. And it's pretty clear that, as with a lot of technology, there's going to be essentially 2 independent ecosystems that will rise up. And it's interesting, like there aren't many secrets in the tech involved in making large language models. So it's basically a race of how much compute can you throw at it. And Alibaba, Tencent, various companies have a lot of compute similar to Meta and Google.
Yeah. And the secrets, to the extent they exist, there are some important ones, but they tend to be at the very, very frontier. And so they'll take some time to diffuse out. Certainly, Alibaba is not at the true frontier. And like a lot of Chinese companies, they are incredibly constrained by the scarcity of advanced chips, right? They don't have access to the best GPUs. They got these kind of crappy sort of 1.5 generations behind type chips that we're starting to see float around an increasing supply there. So that's part of the issue here. It is also part of the reason why so many Chinese companies are focusing on the open source angle, right? There's a lot of reasons why you might want to do that. One of which is you can imagine wanting to train in certain biases in your open source models as a way of exerting a kind of geopolitical leverage over your adversaries. Or if you know American companies, for example, are going to use whatever the best open source model is, hey, maybe make it talk a little less about the Tiananmen Square massacre or how bad the CCP might be treating the Uyghur Muslims or, whatever else. So this is all kind of part of the stuff that's baked in. The other thing is a kind of legal front that's been open here where we've talked about this before, especially with 0.1.ai, where their terms of use say, hey, if you're going to use our language model and there's some legal issue that arises from it, that legal issue is going to be adjudicated in the People's Republic of China. So that's another way that they can get some leverage over what's going on over here. But certainly, Alibaba's made a big push in the direction of open sourcing. Again, like so many other Chinese companies, a disproportionate interest in this, because if you want to be number one at something and they can't be number one at the true frontier AI game, then the main thing that's left to you is play the open source game. At least win that for now. Try to use that to get some headlines. Maybe pull some researchers over to the extent that you can, and go from there. So I think that's kind of where this is all coming from. That leaderboard, by the way, on Hugging Face, I just went over yesterday to have a look, and I mean it's Qwen number 1, Meta, so it's like Llama 370B number 2, and then in the number 3 spot there's Qwen again, 72 billion with Qwen 2, it's the non-instruct version. Anyway, so you see it is quite well populated by those Chinese models, which not super surprising, but definitely noteworthy.
Oh, and worth noting that these are the openly released models on the Hugging Face platform. So you're not going to have things like GPT-4 on there. Next up, here comes Meta Ray-Ban's Challenger with ChatGPT 4o and a camera. So Meta Ray-Bans are glasses that come equipped with speakers and glasses, and as of this year, Meta AI. So you're able to say, hey, Meta, and do all the usual things you can do with AI. You can say, what is in front of me? You can ask it questions, and it will answer. And it's sort of been a little under the radar, I would say. You've seen things like Rabbit R1, Humane Pin, that have been huge flops in the space of wearable AI. these glasses came out. This is the second generation of these kinds of glasses from Meta. And the reviews are actually pretty positive, partially because there's a lot of use for them outside of AI. You can just record videos from the glasses. And so now there is this company Solos, a smart glasses manufacturer, which is aiming to release similar glasses that will have GPT-4o capabilities with a camera. You can ask it questions. And evidently, you will also be able to integrate with Google Gemini and Anthropic's AI models. So there you go. It'll be interesting if this turns out to be the wearable paradigm that people actually want, as opposed to these other, let's say, pretty large failures.
Ouch. Yeah. Actually, it's funny, not to derail us or anything, but I was watching a YouTube video from this channel, CoffeeZilla, and I'm not sure if you follow them, but
oh yeah,
you've seen it, yeah. So they did a thing on the Rabbit R1 and the Rabbit team basically, and how I had no idea they were like a crypto scam basically, as far as you could tell before they went into the space. So maybe maybe just like a hype chasing situation. But yeah, this product looks pretty interesting. It's also, it seems to be competitive with the Ray-Bans in terms of pricing. Maybe, we know that the current version, which does not actually have the video functionality in it, it's just audio only, is retailing for basically $250. So it's presumably going to be more than that, presumably not going to be that much more than that. So hovering around maybe that $300 price point that the Ray-Bans currently sit at.
And I will say, just so it's out in the open, I am an owner of the Meta Ray-Ban glasses. I'm a bit of an early adopter. I'm a fan of Meta VR. I'm a fan of...
No need to flex on, Ray.
I'm just saying, if I'm being very positive about these kind of glasses, you know why. I think I do have a personal opinion that this is a sort of wearable AI that people may actually want, unlike all these other things.
So what's the most common use that you put them to? What's the killer feature for you?
The big one is the video recording and taking photos, just because it means that you don't need to take out your phone. And if you're being a tourist or are at an event, that's a pretty nice feature. You don't need to be distracted by looking at your phone. You can just keep looking at whatever you're looking. This AI integration isn't, I think, yet kind of the main benefit, but being able to take photos via voice commands and being able to ask questions, sort of instead of going to ChatGPT, the website, for really quick things, you can just use your voice. I do think, arguably, that could be very useful.
Where does the audio come from? Or do you get a response? No, you get a video response, right? On the LED, not an audio response to your
You get an audio response. There are built-in speakers in the frames that use bone conduction technology. And so you can play music on them too, listen to books and so on.
Does the audio go into your ear, or do other people hear it as well, or how does that work?
It's using this fancy technology where you can sort of hear it, but for the most part,
like directional
hear it.
Audio.
Yeah.
Oh, interesting. Okay. All right. Well, you heard it here first. $300, folks. I'm sure, Andrey, do you have like a promo link that you can?
Well, unfortunately, we're not sponsored by them, so too bad. But anyways, this is a little, just a bit of personal take. We're not advertising here.
That's great.
And next up, a bit of a spicy story that came out. Apple's Phil Schiller is reportedly joining OpenAI's board. This will be an appointment with an observation component, so not kind of directing OpenAI's actions. And this person is the App Store chief and the former marketing head. So there you go. The deeper partnership between Apple and OpenAI continues to get deeper.
It does. The other thing, too, that's sort of interesting about this, and that jumped out at me when I saw this, was, this is going to be awkward. You've got the Microsoft board observer on the board. You've now got the Apple board observer, like the Microsoft-Apple rivalry, two people on the same board. By the way, Apple not known for taking board seats on prominent companies very often. They have done it a couple times. I think there's a Chinese guy. I think it might have been Didi that they did that briefly on, but not a standard practice for Apple at all. This will give them some visibility into the machinations of what's going on at the board level and how's company business being handled, basically. So that's pretty strategic information. It's just about all they get from it, because it is just like Microsoft observer role, but so some intel that's going to come out of that. You could imagine situations where the Microsoft observer might request that the Apple observer leave, for example, and if they're going to talk about the sort of Microsoft OpenAI partnership in a way that's strategic. Those sorts of requests, as I understand it, are often granted when they are made, but that is a courtesy. So anyway, kind of interesting times over at OpenAI, and just reminds you of how insane it is that Sam Altman's been able to make these deals between Microsoft and Apple. I mean, this is like the original OG tech rivalry. So there you go.
Yeah, it really makes me wonder if in some sense Microsoft isn't entirely opposed to this, in the sense that we have talked about how there were antitrust investigations on Microsoft and OpenAI in Europe and in the US. So similar to how in the 90s, Microsoft kind of propped up Apple in a kind of funny way amid antitrust considerations against them. Well, maybe they do want OpenAI to partner with other companies. On the other hand, it does make me wonder, Microsoft apparently paid and invested in OpenAI for this exclusive license to GPT technologies, which was always pretty vague and unclear on what that means. Well, the exclusivity there apparently is not holding up. So very curious situation.
So that's a great point, number one. Number two, something it also brings to mind, right, is OpenAI's board is, so the voting part of the board, not the observers, but the voting part of the board, is charged with determining when officially OpenAI can be said to have achieved AGI. That matters because when they do, that requirement on the part of OpenAI to share their technology with Microsoft ends. OpenAI is not required to share access to technology that's AGI and above. And so, you can imagine if you have Apple now, even as an observer, maybe influencing conversations on the board, trying to steer things towards, say, recognizing earlier on that they have hit AGI or some similar threshold. That could be an interesting way to throw a wrench in the gears anyway. So we'll have to see. But no, you're totally right. This is it's such a weird situation. We're just completely off the edge of the map here. So we'll see what Phil Schiller does.
Yeah, if there are any antitrust experts, you can definitely feel free to chime in. I think it's very interesting to think on whether that might be a possibility. And the last story for the section, AI video startup Runway is looking to raise $450 million. And that would put the valuation of the company at $4 billion. This is following up on previous raising in 2023. They raised $141 million from investors such as Google and Nvidia and were valued at $1.5 billion. So yeah, you could say that things are heating up quite a bit for Runway. And we'll be interested to see if they actually do raise that amount and increase their valuation by that much. On to projects and open source. First section, Kyutai open sources Moshi, a real-time native multimodal foundation AI model that can listen and speak. So this was a pretty big thing on Twitter, I think, where this model Moshi is pretty much what GPT-4o demonstrated, a real-time multimodal model that you can talk to in near real time. The model was fine-tuned with 100,000 oral-style synthetic conversations and has an end-to-end latency of 200 milliseconds. And so, yeah, people were pretty excited to have a GPT-4o type model. I will say that looking outside the demo at some videos posted on Twitter of people trying it out, not very impressive, but still people are definitely working on these kinds of models.
Yeah, I feel like that's happening an awful lot these days. We've crossed the uncanny valley in demo land, but beyond that, it sort of like reminds me of, I'm trying to remember what the name of that company was, but it started with a V. Anyway, back in the day, there was like this, this is going to crush me. Anyway, there was some company that was really good at doing demos of AI stuff, and it just never came together. And now it's really bothering me. It doesn't matter. Doesn't matter. I'm not bothered by this at all. So this is a 7 billion parameter model, which, surprisingly small, especially for a multimodal model. That's probably where they're getting the low latency from too. It's not that much to kind of propagate through at inference time. But if it's also, not delivering in quality, then that's, maybe a more fundamental issue. But the diffusion of the stuff proceeds at pace. Look, if this model actually worked, you'd have some really interesting questions about responsible use, right? You got a system here that can do the text-to-speech stuff, can do all the GPT-4o stuff. Again, if it actually could, which it kind of can, but really kind of can't. We ought to be asking ourselves, like, what does this imply about, scaled, not just disinformation, but identity theft and all the usual things? If, phone calls, AI-generated phone calls are just an API call away, then that's, probably a bit of a shift in terms of that risk landscape too. But anyway, I'm not at all bothered by the fact that I can't remember the name of that company that starts with a V now. And that's all I got.
That's a good thing. I guess sometimes you got to just let things go.
Yeah, like that company whose name starts with a V. Anyway.
And next, we have a paper, MMEvalPro, calibrating multimodal benchmarks towards trustworthy and efficient evaluation. This is a partnership of a few organizations, and they show that on multimodal benchmarks with multiple choice questions, often the numbers are a little bit wrong. So you can use biases in the questions to answer or guess the answer pretty well without even using the image. There are sorts of things that happen often with benchmarks. You realize after release that the way the models are getting good performance are not really the way you want them to. So in this updated benchmark, there are 2,138 question triplets. 2/3 of those were manually labeled by human experts. And some of them, some other ones are from existing benchmarks. And as a result, this benchmark is more challenging, with the best LLMs lagging behind human performance by 31% compared to 8% in previous benchmarks. And that's, I think, what more and more of these new benchmarks are seeking, actual challenge where the LLMs aren't at human level.
Yeah, it's so interesting, not at all, frankly, how I would have expected this space to play out, like, 10 years ago, 5 years ago. You're looking at it now, it's like we seem to be smashing, human level performance across such a wide range of tasks. And then the ones that we're not, so often it kind of feels like this, this famous like Goodhart's law problem, where the minute that you identify a metric and make it a target that you're going to try to optimize for, all of a sudden, you'll find ways to move that metric that don't actually touch the kind of original underlying cause of that metric being so low. So, you can kind of overfit, let's say, to a particular performance metric and not actually address the substance of what it used to be getting at. You can hack that particular metric. So, this is kind of highlighting that is absolutely an issue, especially in the multimodal domain. Maybe a bit less surprising because that domain is a bit newer. But their big focus here is on the sort of like type 1 error, to kind of abuse my statistics language, a bit of a like kind of false positive type error where you incorrectly conclude that, your model's really good, when in fact what's going on is it's, using cues in the question that kind of don't require you to look at the actual multimodal part of the problem, at the image, for example. If just the way that from the way the question's asked, there's a little bit of information that makes you a little bit more likely to answer the question without even needing to look at the image that it's supposed to be coupled to, then that can be a thing. And I think that's going to be an ongoing challenge here. But a new benchmark that shows surprising gap between humans and AI systems is always good. It's an area for improvement for sure.
Next story, also on model evaluation, and this one is about how Anthropic is pushing for third-party AI model evaluations. So they had a blog post titled "A New Initiative for Developing Third-Party Model Evaluations," where they asked 3 key areas of focus for evaluation development: AI safety level assessments, advanced capability and safety metrics, and infrastructures, tools, and methods for developing evaluations. And so the third party aspect of this is that they are seeking proposals. They have an application form for, I suppose, anyone to submit a proposal for evaluation. They also have a new email address. If you have questions, you can email eval-initiative@anthropic.com. So it makes a lot of sense. I think this is part of the conversations in safety, needing independent overview kind of initiative. And this seems to be in line with that.
Yeah, I was at some conference a couple of weeks ago with I think Jack Clark gave some address about this, and this is basically core to Anthropic's now big governance play. So one of the things that they're imagining is this future where you have these things called regulatory markets, where basically you have the big companies building out their AI systems that could potentially be dangerous, and then you have this ecosystem of smaller companies that are tasked with performing audits and other things like that for those bigger companies. And those smaller companies, Anthropic one day hopes, or at least Jack Clark one day hopes, will have some sort of government mandate or support. They'll be getting certification from those private companies will be required in order for those big companies to release models and maybe do some development work as well. I think that there are some significant issues with this, candidly, in terms of how far you could go with things like misalignment risk, with things like CBRN, like chem, bio, radiological, and nuclear risks, just because you need so many companies to be performing these audits with clearances and accessing very, very sensitive data. But doesn't mean it can't work. And this is certainly them firing the initial shot here, really trying to drum up this ecosystem. They've done a great job of that. They've brought on a whole bunch of great AI evals companies to audit their models in the past. So they're really trying to stimulate that demand at the ground floor, which is just a good thing, right? You want more companies that can do more of these audits. I will say one thing, looking at their AI safety level assessments section, right? This is the thing that one of the three key areas that they want to source contractors for. It was kind of interesting to see them break down the risks essentially that they want to look at their models for. They call out your standard, cyber attack, cyber offense risk, chem, bio, radiological, and nuclear risk. This is sometimes known as CBRN risk. So we've seen that called out before. Autonomy as well. These are like, can the model self-replicate or gather resources on its own? The so-called survival and flourishing evals that we've talked about before. And then there's social manipulation. And then there's misalignment risk. And they kind of have misalignment risk as its own category, independent of autonomy, which I think is both interesting and important. That's, I think, the right call. But kind of interesting that they're separating, right, the ability to self-replicate, to kind of escape if it wanted to, from the actual impetus, the desire to do that, or the incentive to do that. So I thought it was a really interesting breakdown. Anthropic is good at this. They do a good job of kind of laying out in a very structured way, they're thinking on a lot of these risk sets. So great read, and we'll see what comes out of this.
Yeah, hopefully what comes out is no AI doomsday. We'll see.
But then what would we talk about, Andrey?
And one last story for this section is about Mozilla Llama file. And this is coming out of the AI Engineers World's Fair, which just happened in the Bay Area. So the announcement of this Llama file, this is an open source project, and Llama files are these files that package together the weights of an LLM with the software needed to run it. With the idea being that with these files, it will be much easier to deploy models on the device and on various platforms. Mozilla, of course, is a developer of Firefox, so they are pretty big in the open source space. So this is an open source initiative to power local AI. And Mozilla also unveiled this Mozilla Builders project, which is an accelerator that offers $100,000 in funding for open source projects that advance promise potential of local AI. So many companies are trying to become a player in the open source space. An interesting contribution here from Mozilla.
It's also, Mozilla obviously a big contributor to the open source game. That's really become their big differentiator, especially in the last couple of years. But they've always been into it. And hey, the Firefox browser, there you go, big open source contribution. So now more and more so on the AI side. One of the interesting things about this too is that the Llama files are actually going to intelligently utilize, as they put it. They could have said use, could have said use, just saying, but they're going to intelligently utilize available hardware. So for example, they can use a GPU if available for faster performance, or your CPU if it's not ready. So that's kind of interesting that they've done a lot of like optimization and there's a bit of meta awareness of the hardware ecosystem around this thing. It's a single executable file. So just basically, double click, if you will, and start it running. So yeah, really cool and consistent with their wider approach.
On to research and advancements. First up, we have researchers append AI status quo by eliminating matrix multiplication in LLMs. So matrix multiplication is basically most of what neural nets and large networks do. They take some weights, some inputs, multiply them a bunch of times, and that produces the outputs. So this, coming from a university, is offering a way to get around that by using ternary values, a fancy term for just using -1, 0, and 1, instead of floating point numbers, things like 1.1, 1.2, and so on. And they have implemented this matmul-free linear gated recurrent units that can perform basic arithmetic operations and so on. So with the approach, the big benefit is, of course, reducing memory usage and potentially also increasing throughput. And they do have some experiments on scaling up models up to 2.7 billion parameters, showing that they are comparable in performance while using much less memory and having better latency. Yet another example, we've seen 1-bit models also published. This appears to be quite similar. And so we have to wonder, we've seen a couple of papers generate some discussion, but it still has yet to be proven at larger scales.
I think that's exactly right, especially on the sort of speculative nature of this. It is exciting. So just for context, essentially what's happening here is instead of doing matrix multiplication algebra, which is what usually has to go into making a transformer do what it does, what they're doing is something that is something like addition. They're kind of swapping out multiplication for addition. Intuitively, you can see how that would work, right? Like when you're just dealing with 3 possible values, -1, 0, and 1, the kind of operation space is a lot more constrained. And so multiplication and addition start to kind of allow you to reach just about as far in that kind of value space. Anyway, bottom line is addition is also a lot easier, right? It's a lot faster to do. And so by stripping out the multiplication side, you're able to kind of run these things much more efficiently. And they actually do this on their own FPGA, basically like custom hardware, because ultimately everything is so optimized. All the hardware that exists is so optimized for transformer architectures that you can't really, like, if you come out with a new crazy good idea for, these kinds of architectures, you're probably going to find that it underperforms a lot just because it's so handicapped basically by the fact that hardware is so optimized for the current paradigm. One little note here, and there was a blog post that I was looking at on, I think it was Less Wrong, that went into this a little bit. I just looked up the title and this thing popped up. So they highlight a couple of important caveats to this, right? So one of them is the curves that they use. So just maybe for a little bit of context, the key thing that they're doing here is they're demonstrating that the scaling curves that you get for this architecture actually seem to look better than the scaling curves that you get for transformers. So traditional transformers, when we talk about scaling curves, basically we're talking about how low is the loss, how well does the model perform as you pour more compute into it, as you put more flops into the training process. And what they're showing here is that that curve for this addition strategy instead of multiplication, the addition architecture they're using here, that curve is actually steeper. So as you increase the amount of flops that you pour into your model, supposedly you're getting kind of more returns faster. That would be a giant deal. And these curves actually intersect at 10 to the 23 flops or so, which is actually the scale of a lot of current open source models. It's not a huge scale. So the argument here would be it's already better to use this kind of architecture, assuming that the hardware is there for it. The challenge, though, is that they're drawing that conclusion based on 3 points on this curve. They're really extrapolating from 3 points. Given how these points look, I'm just looking at the raw data here, you could very credibly make the argument that this is actually, it could just be noise, basically. So you would, to your point, Andrey, you would want to see this done at more scale. You just want to see more points on that scaling curve plotted out, do more training runs, and verify that this is actually the trend that you expect to hold. Because right now, it could be, frankly, a bit of a nothing burger if it just turns out that, hey, when you actually redo it, you find that the traditional transformer either matches or outperforms this architecture. But still, I think it's interesting and noteworthy that such a simple architecture that just does addition, like this fundamental assumption that I think it's fair to say we all would have made, that multiplication is pretty core to what transformers are up to and the magic that happens under the hood. That doesn't seem to be the case. So, it makes you wonder what other low-hanging fruit might there be, and that's probably a pretty big field of possibilities at this point.
Exactly, and we've seen this a lot with quantization, right, where it's pretty well known now that you don't need all the numbers. You can reduce it to 3 bits, 4 bits, etc. Let's see if we can take it down to 2 bits, I guess, in this case.
I'm just happy that they didn't call the paper "Addition is all you need," because that just
yeah, that would be a little obnoxious. And speaking of a popular paper name formulas, the next one is AI agents that matter. I've seen maybe 1 or 2 times a few years ago, there was deep reinforcement learning that matters that called out the evaluation practices of reinforcement learning and basically pointed out that they suck, that they don't really compare things well because you don't control for things like seed values and randomness and things like that. That's essentially what this paper is doing for agent evaluation. And the big thing they point out is that on evaluation, you cannot just report accuracy. You need to produce the accuracy while accounting for cost, in the sense that with agents, if you just run more of them or run them for longer, you are likely to get better results. So we need standardized benchmarking practices that allow for actual information reproducibility. And there's a few more other things that they do analysis of failure modes, for instance, overfitting on a single task, meaning that they won't generalize, things like that. So I think a very good point for this space. Agents are kind of, you could say, the next frontier that are seeing a lot of work and a lot of investment and so on. We are not quite there yet, but a lot of people think that this is the next thing to crack. And this is one of those things that showcase that we are still a little bit early on the road to that.
Yeah, I really like this paper. It was a great example of kind of questioning some of the basic assumptions that you're always surprised when you see papers like this because you're like, wait, nobody asked this question. But then again, it's not like I did. So there you go. They do a great job. They set up a couple of different baselines that they compare to each other. So for example, they show you GPT 3.5 and GPT-4 models, just like out of the box, 0 shot, no agent architecture. How do they perform? Then they have a version they call retry, where basically you just repeatedly call the model up to 5 times in this case, and try to get it to solve a problem and see how well does that do. Then they have a version that's kind of similar. They call it warming. Same idea, but you just turn up the temperature of the model with each run. The temperature is this parameter that kind of controls the creativity of the model. So how often will it predict, will it generate the word that is maybe not the most likely next word it thinks or the most optimal next word, but one of the kind of from the wings of the distribution a little bit more swing for the fences. So that's that warming example. And then there's this thing called escalation, where they start with a cheap model, in this case, Llama 3, 8 billion parameters, and they escalate to a more expensive one, so say GPT 3.5 or something like that, if they encounter a test case failure. So those are the sort of 4 paradigms, pretty basic approaches, not really your agent-like models that you would expect. And they draw a couple of really, to me, interesting conclusions. One of them is that state-of-the-art agent architectures, at least for human eval, they don't outperform these simple baselines. They find there's no significant accuracy difference between in this case, their warming strategy, so pretty out of the box kind of benchmark baseline, and the best performing agent architecture, at least for this eval. So human eval is essentially a coding data set where you have kind of coding tests that the model has to pass. And like there's no measurable increase in performance with these fancy architectures. Furthermore, a lot of these fancy architectures suck in terms of cost. So not only are you not getting better performance relative to these, fairly vanilla, essentially like prompting engineering strategies, but you're also getting outrageously higher costs. They find that techniques like reflection and this thing called LMB. So this is the language model debugger. They cost 50% more than the just vanilla warming strategy. And another one called language agent tree search, which we've talked about on the podcast before, cost over 50 times more while yielding basically the same results. So then they end up showing this curve basically of the cost of these agents on the x-axis and the accuracy, basically the performance on the y-axis. And they trace out the sort of, the Pareto frontier, as it's called, right? So this is like the frontier of what's optimal. And from there, you can really see how some of these architectures just really fail to perform as well as the escalation or the warming baselines, which are again like not fancy. They're really basic, and so this really calls into question. They're going to argue whether it even makes sense to try with these very expensive, very complex architectures when pretty simple prompting strategies, naive strategies do the trick.
Yeah, and that is something we've seen in many cases, or at least I've seen over the years with deep learning and machine learning. Every once in a while, you have this kind of paper that comes out, and for a given domain, in this case agents, but it's also happened for video evaluation, for question answering in NLP, a lot of different things. It basically says, look, it turns out that these numbers are mainly due to how we are doing the benchmarking, maybe the benchmark itself, for instance, like you can guess the result without looking at the video or the image. And then they say, well, here's a very simple thing that turns out to work way better than all these other things. And so, yeah, very much a useful thing that comes out every once in a while to point out sort of the methodological flaws of the community as a whole. At the lightning round, we start with a bit of a nerdy paper.
This is such a nerdy paper.
It's really quite nerdy, I would say, but we're going to cover it nonetheless. It's called Warp on the Benefits of Weight Average Rewarded Policies. So if I understand correctly, it's tackling this problem of when you do reinforcement learning human feedback on models to align them with what humans do, you're starting with a trained model already with a bunch of knowledge baked into it. And so if you train it some more to make it do certain things that you want it to do, as a result, it may lose some of that stuff that it had prior to this additional training. It can forget pre-trained knowledge. And so usually when you do this stuff, there's a technique called KL regularization, which essentially makes it so the models stick pretty close to what they were prior to the RL. And this paper has this weight average rewarded policies strategy that shows that you can get away a little bit from vanilla KL regularization. You can do some fancy stuff to improve the ability to optimize in the RL stage while still retaining information.
Yeah, exactly. See, that's it. So this is basically from the problem of like, so in reinforcement learning from human feedback, usually what you do is you create this thing called a reward model that you train from a lot of interactions with humans, a lot of upvotes and downvotes of different content. That reward model is naively, you would think, okay, well, I can just train my language model to get a high reward or a high predicted reward to generate outputs, let's say that reward model would score well. The problem is that you end up with these perverse optimizations where the model will then find ways to make that reward model get a really high reward or offer a really high reward, but that are basically just hacks. Like it finds the the breaking points, the ways in which that reward model maybe doesn't fully capture what you want, because how could it? Human desires and values are so complex. And so, yeah, what you do is you say, okay, well, look, head a little bit in the direction of what that reward model wants, but don't change too much, right? We want to make sure that you don't change your behavior too much, and so you include this essentially this anchor, as it's sometimes referred to, this Kullback-Leibler divergence kind of score that says, hold on, you're starting to behave a little too differently from your original behavior. So let's kind of not go off too far in that direction. The perverse optimization doesn't happen. This is a technique that is going to say, okay, for any given fine-tuning run like that, what we'll find is if we take if we, let's say, make 5 different copies of our language model, and we run it through this process 5 independent times, where we'll train it on our reward model, and with that, whatever that Kullback-Leibler thing, so it doesn't go off into some random direction. We'll do the same thing with the second copy and third copy. These copies are going to learn to get high scores in slightly different ways, right? They'll learn to get high scores for that reward model in slightly different ways, and so they'll all learn kind of slightly different things about what humans actually want that was encoded in that reward model. And so what you then do is you train a bunch of these in that way, and you're going to merge them together by, actually, it's a dead simple technique. Basically, it's like averaging their weights together, the parameter values. It's a little bit more fancy than that, but anyway, that's roughly the idea. And then they are going to essentially, there's a fancy way of doing this, but roughly they take that new model they get, and they're going to repeat the process. Okay, use that as the new language model, create 5 copies of it. Again, run through this process where each copy gets trained independently against the reward model and the Kullback-Leibler divergence. It doesn't go too crazy. And then merge them again. And so they go through these kind of independent cycles to gradually get a more and more aligned model, but that doesn't go off the rails. And the results are, are pretty interesting. It's actually, again, one of these Pareto frontier things, because by controlling the number of times they go through that loop, they can more finely control how much do you orient the model towards what the reward model wants, towards your assessment of human preferences, versus how much do you get it to remain as it was, to kind of orient towards that Kullback-Leibler score, so that it doesn't change too much from what it originally contained, the knowledge it originally contained. Anyway, so that's basically the overview. It's super nerdy paper.
Sounds super nerdy, but also worth noting, this is coming from DeepMind. And so while it seems theoretical, it could well have significant impacts in practice, since, of course, the stage of RL from human feedback is essential to developing a good chatbot. Next up, scaling synthetic data creation with 1 billion personas. The authors here introduce this thing called Persona Hub, which is a collection of 1 billion diverse personas of LLMs. They curated this from web data, and these are meant to be sort of different mimicking of different possible ways of thinking, of knowledge, these kinds of things. And the purpose of it is to do this synthetic data generation, generating data that doesn't exist via AI, and then being able to use that for training models. So I like this paper because 1 billion is a big number, and personas sounds cool, and Persona Hub sounds cool. And also because synthetic data is one of these things that might be essential moving forward. It is probably already something that when you look at GPT-4 or Claude, that is part of a training recipe. And so this thing of having different variations of your AI that ensures that the synthetic data is actually useful, that produces varied data, this could be an approach towards that.
All right, cool. So we know that 1 billion is Andrey's big number threshold. That's good to know. So this is actually a really interesting paper as well, because I think it highlights how counterintuitively hard it is to generate a bunch of synthetic data. Like, this is not something that I think most people would think, well, you got GPT-4, right? Just ask it a bunch of questions and you'll get your data out. But of course, you're limited then by how many different ways you can phrase the question, Because if you ask the same question, identically twice, you're going to get the same answer if the temperature is down to 0 modulo some reasons why you actually wouldn't, but that are not terribly relevant here. So this is a bit of an issue. The solution that they came up with was like, hey, wait a minute, why don't we just, if we can create a bunch of descriptions of personas, a gigantic number, let's say 1 billion, so to impress Andrey, then we can actually take those descriptions of personas and append them to a bunch of questions. So, think about like, okay, explain how a rocket works. Okay, you might get one output for that. Okay, now explain how a rocket works for a software engineer, mother of 4 in Oklahoma, right? Okay, now explain how a rocket works for a doctor in blah, 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 right? So depending on the persona that you tailor it to, you're going to get a different output that kind of shares maybe a different aspect of the knowledge that was encoded in the model that you're prompting. And that's important because really when we're talking about generating synthetic data, we're talking about trying to elicit as much as possible all of the information that is contained latently in the model that we're prompting. And the only way to do that is to poke it from every possible direction we could possibly imagine poking it from. And personas are identified here as the way to do that. And the big question is, how do you actually generate the personas? And essentially the technique they're going to use here, the text to persona strategy they'll use, is to give a model a piece of text that they pull from the internet and ask the model to describe the kind of person who would read, write, like, dislike, whatever that text, right? So you're going to get from that a description of a persona. And you can get a giant number of them because you're querying a model. And then you can also, so one of the challenges that you run into with that is you might not actually find that all personas that are possible are actually represented there because the text on the internet is disproportionately written by certain kinds of people. And so they add on to that a persona to persona stage where they derive personas based on the kind of interpersonal relationships they would expect to exist from the first persona. So basically figure out like who are the kinds of people who would work with or interact with the personas that you previously identified. So then you end up with this gigantic set of personas. You trim them down using various techniques to make sure that, because you'll have a ton of overlap, a ton of redundant personas. They do that, they end up with over 1 billion personas. Worth flagging, this is a paper by Tencent AI Lab Seattle. That is a Chinese company for all intents and purposes. And so it's notable that they write, we are open to releasing more data. They release, I think it was about 200,000 of these personas openly, but they say we are open to releasing more data when we can better assess the potential risks and concerns, which will be discussed later in detail. It's basically a CCP lab, but okay. At least I should say Tencent AI Lab Seattle, may have a complicated relationship with Tencent, but it certainly makes you think.
Yeah, and some examples of personas: an enthusiastic amateur golfer who is passionate about combining sports with philanthropic causes, and also a senior software engineer who encourages the undergraduate to consider the social impact of their algorithms, some of the shorter ones they have in the first page, a chemical kinetics researcher, a moving company driver. So that gives you some of the taste. There you go, that they use those personas to create a bunch of data for different interactions. And yeah, there you go. I think a bit of a less nerdy paper because personas are fun to think about.
And there is actually kind of a big headliner here, which they kind of buried this lead a bit, but they do this with an open source 7 billion parameter LLM. It's a Chinese model. It's Qwen 2, right? 7B. They run this hard. They do their sort of fine tuning on synthetic data that they generate that's kind of like math related. And they actually end up with a performance on the math benchmark that beats Claude 3 Opus. So I don't know, a couple of weeks ago, this was the leading Anthropic model. This is the big model, right? It's like Gemini Ultra. It's the largest scale version of the Claude 3 family. It beats this model. It's a 7 billion parameter model. It beats that model basically on, and GPT-4 Turbo, by the way, the preview version, in accuracy on the math benchmark. So, looking at one particular benchmark doesn't always give you the complete picture, but it is noteworthy that when it comes to just, you can do this by cranking out synthetic data at scale. If you have these personas, this technique, at least so far, seems to be real, seems to work quite well.
And one last paper found in the middle, calibrating positional attention bias improves long context utilization. This will be a little bit mid-dirty paper for
Mid-dirty,
this.
okay.
Yeah. So they look at the problem of when you have long inputs to your model, there is this problem of if the thing you care about is in the middle, then LLMs typically are not as good at using it. They're better at looking at the beginning and the end of the input. And it seems like this is a problem known as the loss in the middle problem. And one big reason for it is because of an intrinsic attention bias, where tokens at the beginning and end of input receive higher attention regardless of the relevance, just due to how you compute attention and positional embeddings. So to fix that, the researchers propose a calibration mechanism found in the middle that fixes that bias, and as a result, makes it so you can deal with stuff that is in the middle of your prompt.
Yeah, and the calibration is surprisingly straightforward. Roughly speaking, what they end up doing is coming up with like a dummy, dummy document that they're going to sort of put at various positions in this in the context window and see what is the attention score on that dummy document on average, right? The average attention score across all the tokens in that document, and that's going to allow them to say, okay, well, if it's an irrelevant dummy document. That variation, we can just add that attention score. We can subtract that attention score from whatever we get from our actual kind of document at that position in the context window. And that should give us the kind of calibrated version that doesn't have this positional bias. So yeah, again, like one of these cases where it's so simple, you find yourself reading these papers and it's like, how has nobody thought of this? But of course, there's just so much going on. And the reality is a lot of these techniques don't need to be optimized much to work. Be it because they're operating at crazy scales or everything else is already so optimized or whatever else. So yeah, and interesting that we're still learning such fundamental facts about how the kind of context window works and attention values are computed.
And moving on to policy and safety, the first story has a bunch of stuff in the link, but one main thing, which is with Chevron's demise, AI regulation seems dead in the water. So this is in the US. Recently, the Supreme Court has struck down the Chevron deference, which is a policy that allowed federal agencies to interpret congressional laws. And that is now struck down, meaning that nationwide AI regulation and generally a lot of policies coming from the executive branch of the government are less powerful. And this story comments on that. That means that courts will have to exercise their own legal judgment, and AI regulation will need to go through, be able to survive specific legal challenges. And given that these are pretty technical subjects, we'll see if the courts are able to deal with this.
Chevron deference it's a really big deal, actually. It sounds boring. It's actually not. It's kind of an interesting concept, but it's super, super important. I mean, this is one of the most important, probably the most important policy story of the last year, and maybe the next year too, depending on how things go in Congress. But essentially, yeah, the idea here is anytime right now there's a statute, a legal statute that's ambiguous, right? So if you think about, let me take a step back. It's July 5th. We've just had Independence Day. We're doing a bit of a civics lesson here. It's not going to hurt a bit. It'll be very short, but I think it's important to kind of frame this up. The US government is set up with three different branches, right? You have the executive, that's the president, basically, and the agencies, the departments of government. You've got the judiciary, which is the judges. They basically interpret law and kind of fill in the gaps. And then you have the legislative, which is basically Congress. They pass the laws, then bind the executive branch that determine what the executive can do, and then they get interpreted by the judiciary. Okay, those three branches need to be balanced together to ensure separation of powers. That is a fundamental virtue of the American system. No one branch of government is allowed to accumulate too much power. It's a way of preventing tyranny and all kinds of bad outcomes. Good stuff so far. Now, Congress passes a law. That law is going to contain a crap ton of ambiguities, right? There's no possible way that legislators are going to be able to anticipate every possible contingency, every nook and cranny and possibility space. And so you need somebody to fill in those gaps. You need somebody to say, well, in this particular situation, it's an edge case. The famous saying is hard cases make bad law. Like you don't want to, it can be really, really difficult to figure out how to apply the law in certain cases. So the question is, who is actually going to fill in that gap? Until recently, when it came to issues regarding sort of technology regulatory oversight, the government would defer to the regulatory agencies. So the argument would be, when it comes to matters of finance, if you're looking at financial instruments, if you're looking at stocks, bonds, derivatives, the SEC, for example, just has a ton of expertise. So why don't we just let the SEC interpret what these laws actually mean and then, apply them, because they're sort of like the technocratic experts on this. The idea is that judges do not have that expertise, right? Judges are usually like basically just lawyers who are dressed up in different suits that like pass judgment and interpret the law, but not in these kind of highly technical cases. Well, what Chevron deference did was exactly that. It allowed agencies to be deferred to in the implementation of these rules of regulation. That's been struck down. What this means in practice is we are now going to rely on the interpretation of the judiciary, of judges. And judges are not technical experts, which means you want to basically you're forced to get rid of as much ambiguity in the law as possible. Congress needs to really be careful. If they're going to pass AI legislation, they got to make sure that legislation anticipates all the possible ambiguities that could arise. That, frankly, is very difficult to do. That is a giant additional hurdle for this whole process. I don't think it's one that can't be overcome. We've done a lot of work on specifically this question, but I think Chevron deference is a giant challenge, or it's the fact that it's been kind of repealed or sort of like struck down in a sense is a big challenge. The reality is that AI is it's such a technically nuanced topic. The way scaling works, the way evals work, the way liability ought to work, all these things play into interpreting the law, and you can't expect judges to have that kind of understanding very quickly. So this is it's a big issue. Also, you can imagine if Congress is forced to resolve issues down to insanely high levels of detail in order to basically, like as an Axios reporter said, predict the future. That's basically what they're being asked to do, is like predict every possible way that these laws could be interpreted. If you're going to ask congressmen to do that, well, you're going to have an awful lot more of these petty squabbles that are going to arise, because now you're having to have all these arguments at a higher level of resolution and detail. And frankly, the system was not set up with that expectation. In fact, historically, it was kind of understood that when Congress writes ambiguous laws, it's implicitly delegating authority to agencies to fill in those gaps. Now, what we're basically saying is going forward, so this is not a retrodictive thing, it doesn't apply to past laws, but going forward, Congress is going to have to do this. They're going to have to get down to the level of resolution and detail that regulatory agencies used to have to resolve down to. So this is, I think, a pretty big blow to the US's nimbleness, right? It needs the dexterity to respond to things faster than the legislative cycle can allow, especially in AI. So this is a really, really bad development in my estimation. I think in practice, like, I don't know about the interpretations of the Constitution that went into this. I'm not a lawyer, certainly not a judge, but in practice, the effects of this are very, very harmful. It does come the same week as well as the Corner Post ruling came out, which removed basically a 6-year limit on the rights of affected parties to challenge past regulations. So it's part of a kind of wave of deregulation, which normally I'm all for, but in the context of AI, stuff is moving so fast. You need to be able to defer to a fast-moving kind of executive cycle time rather than relying on judges and that sort of process.
There you go. That's your civics lesson. And certainly I've learned a little bit. So thank you, Jeremie, for being the expert on this one. Next up, NVIDIA to make $12 billion from AI chips in China this year, despite US controls. So these $12 billion will come from those specialized chips that are the H20 chips. It sounds like there'll be deliveries of a ton of them. It seems that NVIDIA will deliver more than 1 million of these chips, and they cost between $12,000 and $13,000 and that's the suggestion of $12 billion in sales. So yeah, there you go. Despite the controls, it's still the case that NVIDIA is doing a lot of business in China, but these chips are about 1/8 as powerful as the very much leading chips that NVIDIA is selling in the US. So the export controls are having some of the intended effect, even though they're not fully shutting down NVIDIA's ability to do business in China.
Yeah, I think this is a really interesting it's a story about the lagging tail of NVIDIA's business in China. Interestingly, by the way, NVIDIA is actually doing more business in China than they were this time last year. But it's as a fraction of their income's grown so much, their sales have grown so much that as a percentage of their business, it's dropped by quite a bit. There are a couple interesting take homes from this. First off, the H20 GPU, you can think of it as like NVIDIA takes an H100 GPU, so like a regular top-of-the-line GPU, and they basically fry some of the circuits and ship it. That's basically how these things are made. The same is true of a lot of the other kind of derivative GPUs that are meant for the China market. One of the things that, so there's an interesting quote from Dylan Patel, who is one of the guys who runs SemiAnalysis. Really recommend this newsletter if you're interested in AI hardware. So he said that although the H20's capabilities on paper are actually worse than their sort of domestic competitor. This is the Huawei 910B chip. Talked about that quite a bit. That's the chip that's based on the 7-nanometer process that SMIC has. So on paper, the H20 should be a little bit below that. In practice, it's actually a decent bit ahead. Especially it's got better memory performance. So the way in which the kind of area on that chip is allocated is just a little bit more optimal than the 910B. The design of the chip is just better, which maybe not too surprising. NVIDIA is damn good at this, and Huawei, while they're getting up to speed in their game, they're not quite there yet. So the expectation here is that this is going to start to change over time. NVIDIA's H20 GPU is going to fail to continue to compete with Huawei's latest and best. And look, those export control constraints that the U.S. government's put in, the Department of Commerce, I don't expect those to get like more permissive. So I think over time, probably what's going to happen is Huawei is going to gobble up more and more of the domestic Chinese market as they and SMIC and other companies like Xinxin kind of pick up their game and allow fully domesticated GPU markets to pop up. Not too surprising. It's kind of an obvious result of the export controls. And it was expected. Like as far as I can tell, internally USG, a lot of the people I talked to, this is where it was going to go, but it is having a desired effect. It is slowing China down. And I think, you got to take the W unless you're NVIDIA, I guess.
Yeah. And just so it's clear, we are not taking sides here, even though we are based in America. We just want to cover this export controls law, and maybe, we might have personal feelings on slowing China down and so on, but we don't want to sound like we are taking sides.
Oh, well, maybe I should be open about my biases. I absolutely am pro slowing China down, but
yes. Yeah, it's true. We should acknowledge that we have biases and that might impact how we cover these things, but also objectively, these are the facts in this case. And another story on those topics, the next one is that Uncle Sam, aka the US, apparently relies on manual processes to oversee restrictions on Chinese tech companies. So this is about the Bureau of Industry and Security, which is responsible for implementing export licensing controls. And it's going into how that agency is struggling because they have these manual processes going back to 2006, and the scale of what they're doing has increased a lot. So apparently the numbers of Chinese entities on their list, which include organizations that U.S. businesses are not allowed to trade with, rose from 218 in 2018 to 787 in 223. So that's 550 additional organizations over a span of 5 years. And so, I think it's worth kind of being aware of, just because this is another indicator of how big a deal all of this is and how the US is really committed to these things. And there's, quite a few interesting details on what this agency does.
Yeah, BIS is really, it's at the Department of Commerce, one of the most important branches of it. It's focused on this whole export control piece. And there was to your point, I thought it was a really interesting stat at the bottom. They look at the 4,000 entity list applications. So the entity list is basically the set of companies that are big no-nos that you can't sell to just without getting a license. And so they have 4,000 applications that were reviewed by the BIS over the last 6 years. And they say around 2/3 were approved. But they were for $335 billion worth. The rest, which were actually for more. So it's fewer of the applications, but they're worth more of the money. 550 billion or so were denied or revoked. One of the important things to note too is my understanding is that for a lot of these things, there's a presumption of denial. So essentially by default, you should expect that you're going to be denied the license to export, which starts to matter a lot when you have organizations like the BIS that are kind of undermanned. And so essentially you got a longer delay between, approval and all that. So, that kind of means that by default, you're not sending these things out, which is, of course, the national security objective. I think kind of a good update on what the BIS is up to. It's kind of like NIST, right? We're relying on them more, and they haven't gotten more funding or as much additional funding as they might need to deliver on their mandate. So, it'd be great to see things like Congress deliver on a little funding package for NIST and maybe for BIS while they're at it.
And speaking of government organizations and programs, the next one is telling us that the US government has launched an initiative to address workforce shortages for the semiconductor industry. So this is addressing shortages of workers projected for the industry by 2030. That's going to use part of the $5 billion allocated to the new National Semiconductor Technology Center that will distribute grants to different workforce development projects. And of course, this is very significant. The US has invested a lot in the semiconductor industry of the US with the CHIPS Act. And it seems that kind of the rate of university completions are just not keeping up. Apparently, of the new jobs projected for the industry as it grows, 60% are expected to remain unfilled. So a big gap in these very specialized skill sets. And there's some good stats in the story saying that 50 community colleges have introduced or expanded programs related to semiconductor technology, and companies like Intel, Samsung, and others have allocated money for workforce development. So yet another aspect of the semiconductor industry that makes it a challenging space to get into, and why governments need to spend hundreds of billions of dollars to even give their national players a shot. And the last story, Bridgewater starts $2 billion fund that uses machine learning for decision making and will include models from OpenAI, Anthropic, and Perplexity. Bridgewater Associates, in this case, will launch this fund, presumably an investment fund that will use AI to make some of the trading decisions. This is part of a general transition to using a more machine learning. And to me, it's interesting in part because the whole theory of OpenAI, basically since forever, was that once we have super advanced AI, it will just make all the money, right? That's the idea OpenAI has run with for a very long time, is they won't be profitable and then they'll just make all the money with AI. And I guess this could be one example of how that might work. AI will just make all the money via being the best investor in the universe. And we'll see how that actually turns out.
I like how that sentence ended. And we'll see how that actually turns out. Yeah. News at 5. I think this is a really interesting public development in this direction. So this is Man, there's so much here. I mean, so there are, this fund is going to start with $2 billion of capital. They've been experimenting with a smaller fund, about $100 million. So that's chump change in this space for a little bit while now, just to confirm this is actually working. Because obviously you need to make sure that, you're training within distribution and testing within distribution. So they've actually been using this at small scales. One interesting note so the guy who's running this is apparently a broader venture that's been spearheaded by their co-chief investment officer. This is a guy called Greg Jensen, who I had never heard of before, but he worked apparently at Bridgewater since 1996, and he actually put his own money down towards OpenAI's seed round. OpenAI's seed round, mind you. I don't know, that's like 2015, I think. Like a long, long time ago, and then was also one of the first, was part of the first money in for Anthropic. So this is a guy who's really, really tracking the space very closely. It should be noted, this is almost certainly not the first firm to experiment with this sort of thing. When you think about, who's leading the way on this sort of like, not just AI enabled, but basically automated trading strategies, you think about Renaissance Technologies Medallion Fund. That's probably the first one. This is a fund that was set up by former intelligence community people that's notoriously secretive, super, super, super AI first. They've been doing things that gesture in this direction for a long time. Think about Jane Street as well. A bunch of companies, bunch of funds in this space that have been kind of, you would expect would be just as forward-leaning, if not more so on this. So this is what we know about. Keep in mind, this is just the public stuff that we know about. There has been interest. There has been interest from, I think there was a congressional report published recently that was talking about concerns over basically funds using AI to potentially disrupt markets, increasing the fragility of markets, but also you can think about in the more extreme limit as these things get more and more capable, right? What's more useful than an AI model that just makes predictions about how stocks are going to move? Well, presumably one that can actually proactively reach out to analysts to get their opinions to inform its predictions. And what's more useful than that? Well, maybe a model that can do that, but not just to get analysts' opinions, but to start to shape their opinions, because that can influence markets. You can kind of walk down that line of causality, and ultimately giving your model more and more of an action space, you get to the point where you start to worry about these things like placing shorts on very unlikely catastrophic events or things like that, and then making them happen. This is a threat model that sounds out there today. Well, actually less and less so, I guess, but that at least we know has been tracked by a couple of people who, let's say, would be interested in the space. So increasingly, hedge funds are becoming a source of potential sort of AGI-ish risk as you see them sort of start to reach further and further into an action space in the direction of fully automated systems. They have an incentive to work like crazy to just pump that bottom line. And those incentives aren't great in the context of technology that gives you more and more of a potential destructive footprint. So interesting nonetheless. This guy's got some deep connections apparently to Anthropic and OpenAI. Hopefully that makes him more aware of some of the safety risks here too. But we'll see what happens with this very large, or not very large fund, this medium-sized fund, because Bridgewater's total assets are over 100 billion that they're tracking right now.
Yeah, definitely. As you say, we know. So I knew all the stuff too about hedge funds. I think we are all aware of these things, right?
It's all basically The Big Short.
Yes. And that's our last story. So thank you so much for listening to this latest episode of Last Week in AI. As we always say, you can find those articles and subscribe at lastweekin.ai. You can also reach out to us with your feedback. We include the emails you can use in the episode description. As always, we do appreciate if you share the podcast with your friends or enemies, and if you review it to give us some feedback, even if it's negative feedback, hopefully constructive feedback. And now we are done, and do enjoy this fun AI outro song.
Tune in. Tune in and we'll make it fun, you see. From AI agents to Chevron, deference with glee. Talking Moshi, it's the buzz indeed. AI agents making moves. moves with speed. Chevron deference, let's get it clear. For all you AI fans, the best is here. Last week in AI, here we go. Talking about Gemini, don't you know? Gen-3 Alpha 2, so fun. Get ready for a wild ride. From the labs to the street, tech news flows. Stay connected, see what tomorrow holds. We've got your AI updates on the rise. Innovations that'll mesmerize. So grab your headphones and join the stream for the latest in machine